Hello everyone. Are you all able to hear me? So let me put a poll question. See, Raju, we will be doing computer vision, convolution neural network, and recurrent neural network. Okay. So are you all able to hear me? Yes or a no? This would be my first poll question to get started. Yep. Please, can you all respond to that poll question that I've put? Wonderful. 100% of y'all. That's amazing. Okay, quickly, if you all want access to the FDP programs for the last 5 days, it's here. Okay, day 1, 2, 3, 4, and 5. And I'm sure today's session should be live. Sorry about that. Just give me one quick minute. I am going to check on what's happening with respect to YouTube live over there. And because a lot of people would be joining using YouTube live as well, but I just want to double confirm once on whether YouTube live is on or not, and that would help us understand on where we stand. And okay, anyways, you have the 5 days of videos which are available here. You might want to watch these videos and look at what was discussed in the last few days. Just give me a minute, sorry. Okay, seems like YouTube live is enabled now. Let me quickly check. Yep, day 6 is live and people will be joining in online as well. All right, a few quick things. We'll go to mind map. Mind map is something which is there in 360DigiTMG. When you type that and when you click on mind map, you would be taken to the mind map section wherein you can do a drop down and select AI and deep learning. Let me click on this. There we go. So we started off by discussing about CRISP-DM, which is Cross Industry Standard Process for Data Mining, wherein we understood about the business problem, data collection, data cleansing, or preparation or exploratory data analysis. We discussed about you know data mining or machine learning, then model evaluation, a few of the techniques. Today, and then we have also briefly touched upon mathematical foundations, and we have also discussed about deep learning primer just to some extent. Today we are going to deep dive into deep learning primer. We discussed that, you know what, human brain, the basic information of the basic unit of information processing is neuron, and this neuron contains input, neuron, and output. And there was 100-step rule which we discussed. We discussed about compositionality. Compositionality means the initial layers. Okay, of course, I'll discuss more about that. Probably it will start making sense. What features would your initial layers capture? Low level features. Next set of hidden layers capture mid level features. And the final set of hidden layers capture high level features. What does that mean? Let me quickly go here and explain. Come up. Yeah, my friend is here. Okay, so you'll have neurons in this way. This is the input layer. What would be there? I mean, how many neurons will you have in your input layer? The number of neurons, which is equivalent to the number of inputs. So if you have 1, 2, 3, 4, 5 inputs, and say you also have an output variable and x1, x2, x3, x4, and x5. If you have 5 inputs, you'll have 5 neurons here. And there will be an additional neuron which is called as bias. These would be connected to the next layer, which happens to be your hidden layer. Hey, how many hidden layers can I have? As many as you want. How many neurons can I have in the hidden layers? As many as you want. Is it mandatory to have equal number of neurons across the hidden layers? Not really. Should the number of hidden layers keep on decreasing as in how you move forward? Not really. It can also increase. It can also actually increase. Okay. And then every neuron would be connected to every other neuron in the forward layer. Every neuron. Every neuron is connected to every other neuron in the forward layer. Connected to this, connected to this, connected to this. Every neuron is connected to every other neuron. 3, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 1, 2, and in this way. When every neuron is connected to every other neuron in the forward layer, this kind of a network is called as fully connected network or dense layer. Fully connected layer, fully connected network, or dense layer, which is also called as multi-layered perceptron. By default, your multi-layered perceptron is fully connected network or dense network. The initial hidden layers would capture the low level information. For example, if you have face of a human in this way. I'm a very good artist, okay? So bear with me on that. So if you have a human face, eyebrows would have an edge. Eyes will have an edge. Nose will have an edge. Mouth will have an edge. Okay. Ears will have edges. Everything will have edges basically. So high level, the initial hidden layers capture the low level features. Then the next set of hidden layers capture the mid-level features. What could be the mid-level features? It could be something like eye of a person, nose of a person, mouth of a person, ear of a person, so on and so forth. These are all your mid-level features. Then the next or the final hidden layers captures high-level features. High-level features means entire face, kind of. And every neuron, apart from your input layer, apart from the neurons in your input layer, every other neuron, hidden layer and output layer neurons, will have two components. What are those two? Integration function and activation function. Integration and activation, basically. Integration means usually people use summation. So I'll take a simple network so that I quickly explain you about this. So it will have integration. Usually that integration is summation. So you take those in this way. And all these neurons connect to the forward neuron, which has a summation. So here, if you have x1, x2, and x3, you'll also have another neuron, which is called as bias, B. Here you'll have W1, W2, W3. These weights are randomly initialized. And then these neurons connect to this neuron wherein summation is happening. So b into 1 is b plus w1 into x1 plus w2 x2 plus w3 x3. You add all of these and you get a summation. Take that value, whatever number you get here, and supply it to your activation function. Okay, you supply it to the activation function. And then you get your output, predicted value. And then you subtract it from the actual value. If the predicted value and actual value, if there is a difference, you'd get error function or cost function or loss function, right? We discussed about the differences, but majorly people interchangeably use error, cost, and loss. Okay, to be precise, it's cost. Okay, so cost or loss. You take the cost function or the loss function after you traverse in that way, go back and update your weights, all these weights. Update the weights such that your error reduces. So you'll have error and say you have weights. Okay, so what happens is your as in how you keep updating your weights, your error surface or the error values should keep on decreasing, and after a certain point your error values will reach the bottom. After that it will start increasing, so you stop updating your weights. This process of reducing the error is based on gradient descent algorithm. It is based on gradient descent algorithm. And this process of updating the weights, going forward, calculating the error, coming backward and updating the weights is called as backpropagation algorithm. It's called as backpropagation algorithm. Not just that. Okay, we also have something else which we need to understand, which we have already discussed as part of a previous discussion, right? About the weight updation. Each time you go move forward, calculate the cost, come back and update the weights, it is called as uh, one iteration. And we, I think, discussed about the variants of gradient descent algorithm. We discussed about batch gradient descent. We discussed about stochastic gradient descent, and we discussed about mini batch stochastic gradient descent, and we discussed about the concept of epoch and iteration. Let me quickly throw some light onto this. If I haven't discussed, then probably makes sense for me to quickly throw some light on this. Say you have your training data. You have your output x1, x2, x3. Okay. We are taking an example of only 3, so I'll put only 3. Y, x1, x2, x3, y, x1, x2, x3, and say you have 1,000 observations. What happens in batch stochastic gradient descent is that you take all the rows one after another. Take the first row, for example, take x1, x2, x3, pass it through your network and get the predicted value. Compare it with the actual value. When you subtract these two, you get the loss or cost. Then go to the second row, take all these inputs, pass it through your network, calculate the error, come back and update the weights. So keep doing it for all. Okay, sorry, you don't update it after each time, basically, my bad. Take the first row, take all these inputs, pass through your network, calculate the loss, and keep it handy. Go to the second row, take all these inputs, pass through your network, calculate the loss for the second row. In that way, take all these 1,000 rows and keep all the 1,000 values handy or 10,000 values handy. And then take average of all of those. You get mean error, right? Take that mean error as an example. Go back and update the weights. So epoch is after you complete or after you traverse all the training examples through your network at least once, it's called as one epoch. It's called as one epoch. And what do you mean by iteration? Iteration means each time you update the weights, it's called as one iteration. So in batch gradient descent, until and unless you pass through each and every row through your network, calculate all those values, calculate the mean error. Now it becomes cost function. Cost function is for the entire data set. Loss function is for each and every row. Now you go back and update the weights. Each time you update, it's called as one iteration. So within an epoch, you'll have only one iteration. Stochastic gradient descent means you randomly choose a value. So randomly, maybe you have chosen row number 10. Take the corresponding inputs, pass through your network, calculate the loss, come back and update the weights immediately. Now take randomly another one. Say randomly you choose row number 9. You take the corresponding inputs, pass it through your network, calculate the loss, come back and update the weights. So here within one epoch, epoch means once all your training samples pass through your network, it's called as one epoch. So within this one epoch would contain 10,000 iterations. So it gets updated 10,000 times. And you also have mini batch SGD, wherein if you choose a mini batch size to be 100, if you say that I want this mini batch size to be 100, then what happens is after every, you divide this data set first into 100 parts because you have 10,000 observations. 100 is your mini batch, or let me put 1,000, it'll be easier. Mini batch, if it's 1,000, you divide this into 10 parts. 1,000, 1,000, 1,000, 1,000. In that way, you'll have 10 parts. Say 1 to 1,000 will be one part. 1,001 to 2,000 will be the second part. 2,001 to 3,000 would be the third part. In that way, until you exhaust all these 10,000. Within these 1,000, randomly choose a value. Okay, randomly choose a value. Take the corresponding inputs, pass it through your network, do the prediction. Take the corresponding actual value, subtract, you get an error. Again, randomly choose a value, pass it through your network, calculate the error or the loss, save it. Randomly choose another value, pass it through the network, pass the inputs through your network, calculate the loss, save it. Until you exhaust all these 1,000. But within this 1,000, there is stochasticity, meaning randomly you're choosing. Once you're done with all these 1,000, once you get 1,000 loss functions, calculate mean error or mean squared error or mean absolute error, something on those lines, which is called as cost function, and then come back and update your weights. So after every 1,000 you update the weights, that means in one epoch, Epoch means you traverse the entire data set once through your network. In this, how many iterations will you have? You'll have 10 iterations. One epoch, 10 iterations. One epoch, 10,000 iterations. One epoch, one iteration. Okay. Next important thing is, which we need to discuss, it might serve as a quick recap also. Let me do it. If your output variable is continuous, your output, if it is continuous, then the loss function that is used would be your mean error or mean squared error or mean absolute error, so on and so forth. And in the output layer, you'll have a single neuron. And the activation function in the output layer would be a linear function or identity function, or just leave it blank. It would choose linear. If your output variable is discrete, and if you have two categories, then which loss function do we use here? Binary cross entropy. Here also you'll have one. And in the final layer, the activation function that we use would be sigmoid or tanh. Sigmoid or tanh activation function. And if the output variable is discrete, and if you have more than two categories, it is called as categorical cross. When it comes to categorical cross entropy, that's fine. Say you have a 10 class problem that you're trying to solve. Then you'll have 10 neurons in the output layer, and you use something called as Softmax is a. These are a few. You understand all these terminologies in Python, you'd just be amazed at the way you understand the concepts. Okay, so quick question here. Now, we calculate for each and every row, Sujana. For each and every row, each and every individual sample, you calculate. Okay, here, question coming your way. If output variable is discrete in more than two categories, then which activation function do we use in output layer? Would you use sigmoid, or would you use tanh, or would you use softmax? Let me see who would get it right. More than two categories, right? If there are more than two categories, then you go with obviously softmax. And if you're getting confused, I think we have in our blog AI. Mm, 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 mm. Okay, this one, let me show. Optimizers, activation functions. Yeah, you can go with this activation functions, right? There are a bunch of activation functions which are here. Yep, I mean, you'd simply love it. There we go. Let me put this here. One of our trainers has written this and she has done an awesome job. Next, let's move on and move to the next step of the training. So here, non-linear patterns. Linear pattern means, say you have a class like this and you have another class which is a blue circle. If you were to segregate these two with a black line, that means it's a linear boundary. This is called as a linear boundary, linearly separable. And what do we use? We use Perceptron algorithm if you want to handle these kind of boundaries. If you have non-linear boundaries, meaning if you have crosses and if you have circles in that way, you cannot simply draw a single line and segregate the classes. You cannot draw a line and say anything which falls above is a pink circle. Anything which falls below is a black cross. You cannot see that. You need to draw multiple such lines, multi-layered perceptron, multiple such lines, and then you can claim that anything which falls inside belongs to one class. Anything which falls outside belongs to another class. This is how we handle non-linear patterns. And trust me, at least I would say 95% of the problems that you solve related to real world practical problems would all be will all be non-linear in nature. So you would obviously end up using a multi-layered perceptron. You can also change the integration function. I was saying that integration function is majority of the time summation, but you can change this to this kind of a quadratic function. This is like your bias. All you're doing here is you're squaring your inputs, and this will handle some kind of quadratic pattern. When I say quadratic pattern like this, there in the previous example we could draw a single line and segregate the classes. Here you need to draw in that way, a curve like that, which is quadratic. You also have spherical function. Spherical means you take the input and subtract it from the weight and square it. This would capture some kind of spherical shape if exists any. But then how many will you try out in that way manually, right? Hence what people do is they do not really bother about making changes to the integration function. They let it remain as summation and then they proceed further. Multi-layered perceptron. You'll have input, output, and hidden layers. And these are all your activation functions. You have identity function, step function, ramp function, sigmoid function, sigmoid, tanh, ReLU, ELU, leaky ReLU, max out. There are bunch of activation functions which exist, right? And when do you use what is experimental in nature? Is experimental in nature. Yeah. And sorry, that's my kids just trying to disturb me. My bad. Okay. One thing is guaranteed, that when it comes to your output layer, if it is continuous, then you use identity function. If it is Discrete in two categories, you either use sigmoid or tanh. If it's more than two categories in the output, then you go with Softmax. For this intermediary hidden layers or all the other hidden layers, you can try out ReLU, Leaky ReLU, Max Out, ELU, Tannet, Sigmoid. Choice is yours. Majorly, what people are using is ReLU and ReLU family because rectified linear unit. This is exponential linear unit, and then you have leaky ReLU. Of course, again I repeat, not to cross sell anything here. When it comes to our 80 hours program, we get into the depth of almost all the activation functions and explain why it is used and all that. But here, all these things are there: state step, step function used in Perceptron, unit step, heavy side step, sign type, ReLU, leaky ReLU, parameterized ReLU, shifted ReLU, max out, noisy ReLU, bunch of those. Soft plus, ELU, sigmoid, tanh, swish, bunch of those. As a good data scientist or AI expert, you are expected to experiment. The one key thing that I would request you to take away from this training would be experiment. Until and unless you experiment, you would not be able to see good results. Okay, Softmax, what happens is it's applied to the last layer, and the goal of Softmax is to take the outputs of all the neurons, the output layer neurons, and convert them into probability values. Simple. That is the only objective of Softmax. Why is that so? Because say you want to classify on whether the image provided to you is tiger or elephant or lion. If you do not use Softmax, what happens is the values which come out of this can be any number or some number. And when you add all these numbers, it will not sum up to 1. But we know that probability values should sum up to 1. Hey, why do we even need probability values? Then how will you decide whether it is a tiger or a lion or an elephant? How would you decide? Based on what criteria, right? So Softmax, what it does is it's going to do some transformation such that these numbers which come out are passed through the Softmax, and finally you get an output. You'll get the probability values. Okay, you will get the probability values. Probability of A, probability of B, and probability of C. We'll get these probability values. These probability values could be something like this. This is 0.73% probability. This is 0.17% probability. And this is 0.1% probability. When you add all these probability values, the summation should be equivalent to 1. That's a rule of probability. Right? Simply put, if you have head and a tail, if you're tossing a coin, you might either get a head or a tail. Probability of getting a head 0.5. When you add these two, it should sum up to 1. That's the same logic which is applied here. Okay, next. So here you have 3, 1, 2, and 3 lines. I mean, it is not necessary that, say you have 2 inputs. You have a hidden layer with 3 neurons. If you have a hidden layer with 3 neurons, that does not mean you'll have 3 lines like that. Okay, it doesn't mean that you'll have 3 lines in the first place, right? It's just for demonstration purpose. Okay, next. How soon you get down the error surface depends on where your weights are initialized. If your weights are initialized here, you go down the error surface in this way and reach the bottom. Okay. Or if your weights are initialized somewhere here, you'll go down the error surface here. It really depends on how your weights are randomly initialized. It depends to a great extent on the luck factor. To remove that luck factor, people use a lot of different techniques. Like they initialize the weights, multiple times sometimes. They look at what kind of initialization really makes sense. A bunch of things go into picture. Next, error surface when it comes to your neural network is not like this, wherein randomly your weights are initialized and you calculate your error. If this is your error and this is your weights are randomly initialized and you have an error. Then what do? You update your weights and your error gets reduced. Again, you update the weights and your error gets reduced. Again, you update the weights and your error gets reduced in that way. And after a certain point, updation of weights would mean error will start increasing. So your algorithm will stop. This is a very, uh, you know, closed form solution wherein the obvious solution here in this kind of, you know, error surface. But usually it won't be like this. It'll be like this, like your mountain ranges, Himalayan mountain range. It would be like that. And if it's going to be like your Himalayan mountain range, you really don't know on whether you're going to come here in this way or would you come here in this way or would you go down this way. We really don't know. Okay, next. It really depends. Say you got your weights initialized here, you get here. Slightly, if your weights are initialized here, you go there. So weight initialization is very important. Okay, and there are various other techniques, by the way. Now, for our ease of understanding multi-layered perceptron, let us ensure that we combine this integration function and activation function together, and let's start representing in this way. It's just a notation, that's it. And say you have a business problem in this way, wherein you have two inputs and you have an output. For our ease of understanding, right, I have not included bias. Just for our you will throughout. It's not just for the input. You'll have bias function or bias neuron throughout. That's how it would be. Bias will be there for every other neuron apart from your input layer. Okay. So this context setting should be clear. You have two inputs. You have an output. Input layer has two neurons. Out and there are two hidden layers. One hidden layer has three neurons. Another hidden layer has two neurons. 3, 2 in that. How many ever you want, you can use. Each neuron is connected to each of the other neuron in the forward layer. If every neuron is connected to every other neuron in the next layer, what is it called as? Let me go for a poll question at this point of time. So, question for you is as follows. If every neuron is connected to every other neuron in the forward layer, then the network is called as fully connected network or dense network or MLP or all of the above? Yep. Please, can you answer this? Yeah, very good. 75, 70. Actually, all of the above. Dense network or fully connected network or MLP all mean the same. Okay, all mean the same. All right. Next. So let us understand on how this backpropagation algorithm works. So you have, say, two neurons. Neurons are also called as nodes. And these connections are also called as vertices or edges. Okay. Oh, sorry. These are called as edges. Okay. These are called as nodes or neurons. Now, weights are randomly assigned. Okay. So these two are going as input. This weight into this input plus this weight into this input. This is the summation part or the integration part. That will go to a function, activation function of that. That would give you an output which is y1. So you got y1 here. Next. You take x1 into this or this weight into this plus this weight into this. You have the summation part. And then you have activation. You take the summation, pass it through your activation, and then you get an output which is y2. This weight into this plus this weight into this. You take the summation part, pass it through the activation, and then you get an output which is y3. Okay, so you get y2, y1, y2, and y3. These weights are randomly assigned, mind you. Okay. Next, these weights are also randomly assigned. So this weight into this w1 plus this weight into this plus this weight into this, you get the integration. You pass that into the activation component, and then finally you have an output which is y4. Then we have y4 also. Now next, these weights are randomly assigned once again. So w15 into this plus this w25 into this plus w35 into this would give you the summation component. You pass it through your activation component, and when you solve it, you get this output, which is y5. Then this weight into this plus this weight into this, you take the summation and you pass it on to the activation function. When you solve it, you get the output. This output that you get here is your predicted value. So you have your predicted value, but then is your predicted value and actual value the same? Right? We need to ask ourselves that question. So you have the predicted value, and here you have the actual value. When you subtract this actual and predicted value, you get error, or let me put it as loss function. Once you get the loss function, You now go back and update the weights. It is like, say you're the vice president of a specific project. You presented something to the client that's like a predicted, but the client expected something else. So the difference between what you submitted to your customer versus what your customer actually wanted would give you the loss function. Means that's the error kind of. Customer is like, hey, I expected this, you're giving me this. Your bonus will be impacted. Immediately, what will your vice president do? He'll come back, furious. And he will say that, hey, who are the project managers who have given me an input? Y5 and Y6 will say, sir, we have given you the input. Do you know what? My bonus is impacted, so I'm going to impact your bonus also. Then immediately Y4 will say, oh, why do you want to impact my bonus completely? I only contributed W46. So vice president will say, okay, that much amount of penalty I'm going to give you back as a fine, as a deduction on your bonus. Wi-Fi will say, sir, even me, I didn't contribute completely. I contributed only W56. Only so much was my contribution. Okay, W56 into the error. That would be your contribution. That will be the penalty levied on you. These project managers are now very angry on the team leaders. They come back rushing saying that, hey, team leaders, you know what? Our bonuses are impacted because of the shabby work that you have done. Two project managers that, hey, uh, bonus got impacted. Then this team lead would say, you know what? My contribution was only limited. How much did you contribute? 4 to this project manager, to this project. Okay, then take back that much amount penalty. Then these two project managers also go to another team lead. This team lead also will say, hey, my contribution was W34. Okay, and I also contributed W35 to this project manager. So that much amount of penalty is given back. And then that's how you come until here. And then now what you do is you update your weights. And we know for a fact that new weight is equal to old weight plus eta. Eta is also called as learning rate into your loss function, which is nothing but actual value minus predicted value into your input. So new weight is equal to old weight plus eta value into actual value minus predicted value into input. That's what is given here. That's how you keep updating the weights. And this learning rate we have actually discussed, right? Learning rate is also called as eta value, which ranges from 0 to 1. If the eta value is close to 0, then what happens is, if this is your error surface like that, it will take infinite steps to reach the bottom. Infinite steps. A lot of time. And then if your eta value is close to 1, then it might miss out on this and jump here. So this minimum error surface or valley is missed out. Okay, this is how the weights are updated. This is how the weights are updated. Yep. Okay, next. A few network topologies, which we have already discussed, by the way, right? This is your input layer. This is your hidden layer. And here you have output layer. Output need not always have a single neuron. You can have 2, 3, 400, whatever, depending on the problem you're trying to solve. Next, this is your input layer, and you have two hidden layers. One hidden layer has 3, another has 3. As I've told you, the number of neurons within your hidden layers need not be symmetrical. I mean, 3, 3, 4, 4. It need not be like that. You can also have 5 here. Doesn't matter. Or you can have only 1 here or 2 here. Doesn't matter. And then finally, you have your output layer, which has a single neuron in this scenario. Okay. Question to you all, there are two diagrams which are given. This is A and this is B. I want to know on is A perceptron or multi-layered perceptron. So let me put a poll question quickly here. The poll question is figure A, let me put it this way. Which algorithm would suit figure A? Is it perceptron or is it multi-layer perceptron? And yep, please can you answer that? Figure A versus B. Which one is perceptron and which one is multi-layered perceptron? Let me see on how many of y'all got it right. Perceptron, exactly. My dear friends, perceptron algorithm is that algorithm wherein you'll have no hidden layers. You'll have no hidden layers and you will have a single output neuron. Okay, you'll have a single output neuron, right? And what is this B? Obviously, it is a multi-layered perceptron because you have the data, you have say 3 inputs, and then you have hidden layer, one hidden layer with 2 neurons, and then you have your output layer. Okay, so mathematically we calculate this as part of our actual program, but here let's not get into that bit because we'll not have time otherwise. Okay, deep learning libraries. What is a library? Library is collection of code, collection of code or functions which someone else has written in the past. Someone else has written in the past and you want to reuse that. To reuse that code, you need to run those specific or install those libraries. You have something called as Torch, which came to us in 2002. Then you have something called as Tiano in 2009. Then you have Cafe in 2012. Then you have TensorFlow in 2015. Okay, and then around the same time, there is something else which came, which was called as Keras. 1 year down the lane, there came another thing called as PyTorch. Do you know what? Today, as we stand, the 3 things which are ruling completely the world is TensorFlow. Keras is kind of a wrapper, which is a high-level programming language. This is called as high-level programming language. Means what happens is you write some program which is very easy, business friendly, and low level is TensorFlow. High level is Keras, low level is this. That means whatever you write in Keras, your Keras will go and execute the code with the help of the low level programming languages such as TensorFlow or Theano or CNTK. All this, brush it aside. People are using only TensorFlow and Keras combination. This is one thing. Second thing is people are using PyTorch. You might feel that, hey, PyTorch is not that good. But then if I were to, this is 2017. Okay. As of today, let me show you Google Trends. You go to Google Trends and type TensorFlow. Let's see what is the demand for the last 5 years. Trend would be much better. Okay. And let me select worldwide. The demand for TensorFlow is kind of reducing. Yeah. This is from Google, by the way. TensorFlow is from Google. And then there is something called as Keras. Here is a demand for Keras. That's also kind of stabilizing. And there is another thing called as PyTorch. Wow. PyTorch is there. I mean, I've been following up since the lockdown began, and then PyTorch is like going crazy. So I think the future will belong to PyTorch. Why? Let me also tell you guys this that for TensorFlow, the learning curve is steep. I mean, it's slightly difficult. Simple. It is just like that. Walk in the park. It's more or less like English language. PyTorch. Okay, but then okay, let difficult to program. If I were to compare these two, very easy to program. Very fast. Very slow. I would not say very slow, but slow, certainly slow in comparison to TensorFlow. Okay, if I bring in the ease of Keras and the speed of TensorFlow, if I were to combine these two and then launch it together, then in some sense, these are the features which PyTorch has. It's fast as TensorFlow, and it is not extremely easy as Keras, but it's not as difficult as TensorFlow. So I would say it is easier. Since both these combinations exist in PyTorch, people are going. Would we be touching upon that? Not really, but then we would be discussing about Keras because that's a lot easier as a front end. We'll be doing the programming in this, and we will be using TensorFlow as a backend. We'll use TensorFlow as a backend and Keras as the front end. And we shall just proceed further. And then this just look at this, and figure out what happens. We can also look at what is it that we are using to a great extent. Job opportunities important. I would say majorly it is still TensorFlow, but then Keras, PyTorch has slight demand, but PyTorch will rule the world, my dear friends. Take my word on that. PyTorch is the future. What happens in India is anything which is implemented in the Western world, we have a tendency of taking that. All right. Google has messed up with a map, is it? Big time. Anyways. So it's an hour now. Let us quickly take a break. Okay, let's take a break for 10 minutes and then we would be back. We'll write it down here that it's going to be break time and we shall get started at 6:10 p.m. We shall start. Okay, please take a break, quick 10 minutes and come back afresh. Okay, let us proceed further and discuss more about the algorithms. Okay, so now that we discussed enough, we will get into hands-on. But then quickly, I think there are only a few key slides which exist. Error functions or loss functions, or most loss functions or error functions are non-convex in parameters. Okay, and as I've told you, if you initialize the weights, if the weights get initialized here, they go to the bottom here. And if the weights get initialized here, they get to the bottom here. So you'll get different local minima based on different initializations. When it comes to deep learning algorithms, there is lack of interpretability. Okay, people cannot interpret the results. What does that mean? Let me quickly tell you. Say you're using something called as linear regression. Linear regression. Here, what happens is you'll have an equation like this: y is equal to beta naught plus beta 1 x1 plus beta 2 x2, in that way. Say you want to predict the mileage of a vehicle. Mileage is equal to, say, beta naught is 216 plus 1.8 into horsepower. What is the speed of the vehicle? I mean, how powerful the vehicle is, kind of, plus say 1.2 into weight of a vehicle. Here, this 1.2 means that for every 1 unit increase in weight, for every 1 unit increase in weight, that unit could be kgs, pounds, anything. If it's in kgs, for every 1 kg increase in weight, I'll put a negative sign. For every 1 kg increase in the weight, mileage will reduce by a factor of 1.2. Once again, I repeat, for every 1 kg increase in weight, mileage decreases by a factor of 1.2. This kind of interpretation exists when it comes to linear regression. But when it comes to your neural network algorithms or deep learning algorithms, equation will be like this: y is equal to bias plus w1 x1 plus w2 x2, in that way. And say you are trying to predict the mileage of a vehicle. It depends on some numbers, say 169 minus 1.3 into horsepower, okay, minus 1.36 into weight, in that way. This minus 1.36 and minus 1.3 or plus 1.3 or plus 1.6 do not have any interpretation as such. You cannot interpret the results or these weights. Hence, this neural network algorithm is also called as black box technique. You will know exactly on how to calculate these weights. That you can do all the equations. But then when it comes to interpretation, you cannot interpret. Okay, that's another thing. Ablation methods with various arguments. That means which, how many hidden layers should I have? Number of hidden layers. Number of neurons in the hidden layer. In the hidden layer. Which activation function should you use? what is the activation function that you need to use, and then what should be the optimization algorithm, gradient descent algorithm. Which optimization algorithm do you actually want to use? All these are a few things on which you do not have a control on. Learning rate. The only way to figure out what is the best combination of these parameters is by actually um, experimenting. And you know what? Manual experimentation is what you can do. Or also there are a few grid search algorithms which are available. Grid search. I majorly make use of grid search algorithms, right? That will help me a lot, basically. And then since there is no explainability, that is, since you cannot interpret the results, since the results cannot be interpreted, it's called as black box technique. You cannot use neural network in those scenarios where interpretation is required. What could be that scenario? One second, sorry. If you're working for a client in, say, European Union, in European Union, EU, they came up with something called as GDPR, General Data Protection Regulation. According to the GDPR norms, if a bank rejects a loan and if customer demands an explanation, you need to provide explanation. Pretty simple. If you say that, do you know what? I've used a neural network algorithm and my algorithm told that I need to reject the loan. But why? Which variable? Which variable was negatively contributing? Was it my age, my income, my credit score, or which variable? You should be in a position to explain to the customer. Hence, using neural network or black box algorithms or deep learning algorithms everywhere does not make sense. Also, when it comes to life sciences healthcare analytics, okay, when it comes to life sciences, there also a lot of interpretation is required. If you cannot interpret the results, then Medical Council of India or whatever, different countries have different associations with respect to medical, they are not going to approve, they're going to reject. Okay, yeah, so these are the things that you need to remember. And there is something called as explainable AI. And as part of explainable AI, people are trying to come up with explanatory power, the interpretation that does not exist. They're trying to bring in that interpretation. And who is working on it? DARPA. DARPA stands for Defense Advanced Research Projects Agency. That's US Department of Defense agency. And DARPA, they started working on autonomous or driverless vehicles long back, even before people started thinking about that, right? And you cannot reproduce the results easily. Why? Because each time you run your algorithm, the weights are randomly initialized. Sometimes the weights might get initialized here, sometimes the weights might get initialized here, sometimes the weights might get initialized here. So your weights might get initialized at different places. Okay. So the key takeaways until now, whatever we have discussed, would be what is a simple neuron, what are the components of neuron, which is we have integration function and you have activation function. And there are plethora of activation functions. However, depending on whether your output variable is continuous or not, you choose a few. For the output, whether it is discrete in two categories or discrete in, you know, more than two categories, it really depends basically. And we have discussed about Perceptron, we have discussed about multi-layered Perceptron, etc. Now we need to get into the first hands-on. And before we get into the hands-on, I wish to tell you that Python is something that you want to download. But the disadvantage with downloading Python directly is that the look and feel is not that good. Okay, Python was created by Guido van Rossum in the year 1991. That is when it was released. It's uh, almost what in 1990, and then just keep counting how many years has it been? Roughly 30 years, 3 decades. Okay, but Python started off as a scripting language, and then people tweaked it to suit machine learning, deep learning, data science, so on and so forth. Let me show you on how Python appears. So if I just type Python here, a lot of people also keep asking me on, hey, is Python good to go? Is it a good tool? Absolutely. When it comes to programming, it's far, far simpler. Okay. So you have Python. You can just type in that 1 plus 1. And if I click on enter, it says it's 1 plus 1 is 2. Okay. 1 plus 1 is 2, basically, right? So the bad part is the UI, user interface, is not that good when it comes to Python. So what we shall do is we are going to download. I mean, you can just click on this and you can click on downloads and you can download Python. But remember one thing, whenever you download, ensure that you go with one version or two versions lower. If suppose 3.8 is the latest version, go with 3.7, because a lot of issues that you would have had in version 3.7 would have been fixed already. If you still are getting any errors, search and you'll find the solutions to that. The open source community would have solutions to the issues. But then if you go with the latest version, not many people would have had would have gotten their hands on to this latest version. So you'll start getting errors. Okay, you should be cautious about that. Okay. Anyways, this is one thing that you might want to install, or you might want to download Anaconda. I would say go with Anaconda. Anaconda is called as a distribution platform. What Anaconda does is it will bring in Python, R Studio, all of that. It will combine them and give it to you in one installation. Okay, so when you click on download, Anaconda is also operating system agnostic. What does that mean? Here, your Python is also operating system agnostic. It can run on Windows, Linux, Macintosh, or on any of those. If you go to Anaconda, it can be installed again on Windows or Macintosh or Linux. Depending on whether you're using a 64-bit machine or a 32-bit machine, you have to download one of these softwares. If you're using Windows, if Mac, you can download any of these. Linux, any of these. Okay. If you want to check on which version you are using, you can just say my computer, basically right click on that and click on properties. And here it says it's a 64-bit operating system. And you have a 64 bit based processor. So it's 64-bit basically. Yeah. Anyways, you click on that, install it, and when you launch Anaconda for the first time, after you download and install, it would open up in this way. Okay, here, when you open Anaconda for the first time, you'll have a lot of IDEs, integrated development IDEs. And you can use any of the IDEs that is Spider, sorry, Jupyter, and you have Spider. A few of our trainers, other trainers and consultants use PyCharm, and so on and so forth. I'm going to use Spider because it sounds good, right? Name of an animal, Python is the name of an animal. Reptile, right? Snake. Anaconda is also snake. So all are names of animals. So I would choose rather a name of an animal. Spider. Yeah. Okay. That aside, do you know what? I have always been an R guy until I think 2014. Okay. Because back then Python wasn't that famous. Even until 2015, Python wasn't that famous in the field of data science and machine learning and AI. And after that, people started using Python very extensively. And when it comes to deep learning, Python is a go-to programming language for you guys. And while I was working in this, it was called as statistical programming. It wasn't called as R programming. It wasn't called as data science. That term itself didn't exist until 2012. Okay. So I'm going to click on this spider launch. It's coming up. Yeah. It's very, very colorful. Okay. When you open your spider for the first time, this is how it appears. And when you want to have this look and feel that I'm showing you now, all you need to do is go to View, Windows Layouts, and there is something called as R Studio Layout. You need to click on that. Go to Windows, sorry, View, Window Layouts, go to R Studio Layout. When you click on that, you'd get, there is another software called as R Studio. The look and feel is very similar to that. I'll just remove these. And let me zoom this. If you just press Control and this, if you press Control Shift and this will also zoom. So I'm going to type here. So if you type 1 plus 1, for instance, and click on Run, let's say output is 2. Okay. A bit of programming is needed. Programming knowledge is needed, basically. Okay. And let me go and fetch the. We've also done similar kind of programs, so I'll go there and take this. Wonderful. And we will run this. All right. Even before we proceed further, the same concepts, we are going to discuss about. What are the various libraries? NumPy is called as is used for numerical calculations. SciPy is used for scientific calculations. Pandas is used for data manipulation purpose. Scikit-learn, sklearn for machine learning purpose. Plotlib is used for data visualization purpose. Seaborn is used for advanced data visualization purpose. TensorFlow, Keras, PyTorch. These three are majorly used for deep learning purpose. We are going to make use of whatever is needed and proceed further. Okay. So until I load the data, I will not explain about the business problem, but then let's proceed further. If I do a Control L on the keyboard, it will clear the console. I'm going to run this. Import NumPy as NP. Then I imported this. Then if you import from Keras, you go to something called as models. And then you're importing something called as sequential. What would that do? You know for a fact that look at what it is doing. It's saying that it's okay, sorry. The latest version of TensorFlow says that it should be imported in this way. TensorFlow.keras. So I'll just copy this and then wherever need be, we're going to install that. Okay. Let me run this in this way. Okay. A few are very, very specific to Keras, by the way. Anyways, sequential means you're going to take your input layer, then your hidden layers, then your output layer in that way. Hence, it's called as sequential. Sequentially, one layer after another. Dense means every neuron would be connected to every other neuron in the forward layer. Okay, every neuron will be connected to every other neuron in the forward layer. And a lot of important things which we are going to discuss here is np underscore numpy underscore utils is utilities. When do we use it? Where do we use it? I'll let you know. And we already discussed about the seed concept, if you remember. Why do we have the seed? To ensure that each time you split your data into training and test, the same data appears in training and the same data appears in test for that purpose. I think we discussed this in our third session, if I'm not mistaken, right? And you're importing pandas as PD. Hey, import pandas is a way to import this library. I understand that, but why as PD? Okay. If you don't mention this as PD, what happens is, what is pandas used for? Data manipulation purpose. It can also read the files. Okay, now if I don't import as PD, what happens is I have to give pandas dot read underscore CSV. I should write it in this way. Pandas dot CSV. The complete name of the library should be given. Within that, sorry, dot. Within that, you want to read this. So read underscore CSV. And within the brackets, within double quotes, you're giving the complete path of the dataset along with the dataset and extension dot CSV. Let me minimize it a bit further. Okay, so I'm reading the file. Pandas.read_CSV will read the CSV file. Within the double quotes, we are giving the complete path of the file along with the name of the file. And I'm storing it in something called as train. And pandas.read_CSV within the double quotes, you're giving the complete name of the file. It's a .csv file. And you're reading it and storing it in test. In this training data, what is this training data dimension? It has 5,000 rows and 785 columns. Do you know what this data is all about? Let me explain now. There is a specific data set called as MNIST data set. Okay, this MNIST data set is very, very famous basically. And there is a specific database called as MNIST database, modified National Institute of Standards and Technology. It has data of 60,000, or rather in total it's 70,000, but 60,000 examples in training data of handwritten digits. People have written digits such as 0, 1, 2, 3, 4 in that way. What are you expected to do? What is your algorithm expected to do? It is supposed to read these digits and identify on what is there in that particular box. And where is it helpful? Basically, it is helpful in various places. For example, the smart hospital thing that we have come up with. Let me see if I can show you those slides. Where would I get it is something that I'm thinking about. I think manufacturing. It's there in manufacturing analytics. I think it's also there in life sciences, if I'm not mistaken. Let me see. It's not here. Um, Let me see if I can get there. Wonderful, it's there. So let me explain this briefly. So this is a smart hospital basically, and we have built a few AI-driven bots for their physicians, doctors. And how does it work? Right? How does it work basically? If you are a person who wants to book an appointment, if you're a patient, if you want to book an appointment, you are just expected to open the mobile application, record your 6 seconds video or so. Using that, image processing is done here. And you also need to provide your vehicle number, your name, etc., etc. And say you started your journey in a vehicle to hospital. So you seated and you started to hospital. And then here at the entrance of the hospital, say there is a barricade. Here there is an IoT sensor which is placed. This IoT sensor will track the number plate and it will do the mapping against the number that you have given. If there is a match, then automatically this gate will open up automatically, and then you go in. When you travel inside, you will be taken to the nearest parking lot, which is empty. Say a parking lot here is empty. It will take you there. How? Using geofencing, because within your cellar, right, GPS doesn't work. So you need something else that's called as geofencing. Once you enable your mobile, geofencing will be enabled. And then There is also, I mean, how does it identify whether this slot is empty, parking lot? By looking at height sensor. This is your vehicle. There'll be a height sensor. If there's no vehicle, height is complete. If there is a vehicle, height reduces. The moment height reduces, it will blink red color, meaning parking is full. Otherwise, parking would be available and then you can go. Say after parking a vehicle, you went inside the hospital. Here, there is a box which is not visible actually. It will be similar to this box here. Hmm? Like an ATM machine. There you just stand and already you've supplied your 6 seconds video. So it will automatically recognize you and determine that it's you. And then it will ask you to do it yourself. You measure your height, weight. This is a height and weight sensor. Then you sit on this, capture your various vital parameters. It'll be visible here. Once that is done, you go and have a conversation with the doctor, physician. Usually what happens, conversations are not recorded. The prescription which is given on a piece of paper, which also is not recorded. Most often than not, you lose it. Doctors don't keep it. So how can I identify the historical health conditions of the patient? Only if I can record. So doctor wears a Bluetooth. An entire conversation which doctor has is converted from speech to text and it will go and sit in a database in a nice tabular format wherein first name, last name, gender, what symptoms you had, all those details are captured. After that, doctor will speak with you about the prescription. That automatically gets recorded here and automatically gets displayed on your mobile device. The chances of you losing is bleak. Then you go and stand here in front of this using again video analytics, image processing. It determines you, recognizes you, and then it will generate a bill for you. You pay the bill using card or swipe or cash or whatever be it. And then after that is done, you move to the next ATM machine here. And in this next ATM machine, actually medicines are dispensed. How? Robots, using robots. Awesome. Smart hospital in Malaysia. Awesome. And we had a significant contribution on key components. This is me, by the way. When I went to visit after we have done the project, we were invited. We also have our office in Malaysia. So this was their experience center. Okay. So here, the number plate recognition, and there are a lot of other things, but number plate recognition is easy to understand, right? That is where you can use this digit recognition. Of course, they're on a plate, vehicle plate. It's not handwritten, but still you can recognize. But if you handwritten digits, for example, say you're sending a courier or a post, you write the PIN number 5000049. A few people write in a funny way. This looks like this. Okay, this looks like this. This looks like this. So it's very difficult to identify that this is 5 and this is 9. But you have to still recognize. But you have to still recognize. Okay, so this algorithm was trained on these numbers. This algorithm was, you have to train on these handwritten digits. So modified National Institute of Standards and Technology gives you a lot of handwritten digits which are labeled. Label means they give you the image and they'll say that this is 0. They'll give you an image and say that this is 1. They give you an image and say that this is 2. Okay. And in the postal department, for automatic segregation, for automatic processing also, recognizing handwritten digits is very important. Once you get an image, and all these images are black and white images, by the way. 1, for example. All these are grayscale images, black and white, which has a dimension of 28 by 28. You'll have 28 rows and 28 columns. And 28 by 28 is how much? 784. So you split that into various pixels, 28 by 28. You take each pixel and place it in a table. Place it here. Take each pixel value, place it here. Take each pixel value, place it here. Okay, each pixel value in that way. And that is a data set that you have here. And this in the training data you have, though this MNIST data set has 60,000 training images and 10,000 test images, here we have just taken 5,000 rows and 785 columns. Column number 1 is your output variable label, and pixel 0, pixel 1, pixel 2, all these are the various pixel values. Since each image is of 28 by 28, you have 784 pixels and you have an output. So in total you have 785 and you have 5,000 examples. And when it comes to test data, you have 1,000 examples and 785 columns. Next, what we are going to do is each of these has X and Y, right? Since each of those have X and Y, we are going to segregate X and we are going to segregate Y. How do I do it? If you go to this training data, let me open that. If you go to this training data, and if you go to index location, do you know what this is called as? Index number 0, index number 1, index number 2, index number 3. Indexing in Python starts from 0. Row number 0, row number 1, row number 2, in that way of data. So you're saying go to this training data, go to the index. Whenever you have the square brackets, it is always rows, comma, columns. And here you're putting just a colon and leaving it blank. That means you want all the rows, right? That means you want all the rows. And how many columns do you want? You want columns from 1 until end. So column number 1 is this, pixel number 0 until the end, colon, and then you left it blank. So till the end, basically. And what are you doing next? You're taking dot values, means you're taking all the values. You're going to training data, index location. You want to take all the rows and columns from 1 until end. And then you're taking all those values and you're also converting that to a float format. What does this float format mean? Numbers that you're seeing, though you're seeing all zeros. Okay, if I just scroll it in that way, you will have all the various digits come up. It's not appearing. Okay. So see, here you have numbers, all these pixel values. So these are all the pixel intensity values. And for grayscale image, the pixel intensity values ranges from 0 to 255. 0 means black, 255 means white. It ranges from 0 to 255. 0 black, 255 white. Anyways, next. When it comes to your neural network, how are weights assigned? Randomly the weights are assigned. And you know what? These weights, which are randomly assigned, W1, W2 in that way, all these will be in decimal format, majorly in decimal format, like 1.06, right, 0.07. In that way, they'll be in decimals, plus or minus signs. Decimal means floating format, float format. If you have non-decimal numbers like 1, 2, -1, 0, -2 in that way, these are called as integers. And the pixel values of images, pixel intensity values that you pick, would be in integer format. All these pixel values will be in integer format. And weights are in decimal format, that is float format. This x1, x2, x3, all these pixel values would be in integer format. Weights will be in float format. If you multiply integer with float, that is, if you do w1 x1 plus w2 x2 in that way, all you're trying to do is you're going to multiply your float value, which is decimal. Weights will be in decimal format. You're multiplying it with integer value, and then it will throw error. It will say, oh my god, what are you guys trying to do? You're multiplying integer with a float? I don't understand. Hence, we are going to convert these inputs. Weights, anyways, you don't have a control. You cannot convert those to integers, because the only place where you have a control is on inputs. So what will you do with the inputs? You're going to convert those inputs to float format, so that when you multiply float with float, you get a result, not an error. That is the reason why you're taking the data set, index location, all the rows, columns from 1 until n, take all the values of that and convert that to float format and store it in this. Okay. Go to the test data, go to index location, all the rows, columns from 1 until n, take and convert that into a float format and assign it to go to the training data label. So if you go to train dot label, that is train dot label would refer to this output variable. Train dot label dot values. You take all the values. Dot as types. As type means you're converting that to into a float format and assigning it into y underscore train. You're saying test underscore test dot label dot values dot as type. You're converting that into a float format and assigning it to an object called y underscore test. Okay, now another thing that people usually do is they normalize or standardize the data. We discussed normalization, if you remember. When you apply that, values will be in the range of 0 to 1. We discussed. That is exact. We know for a fact that when you look at a grayscale image or a color image for that case, the pixel intensity values range from 0 to 255. Okay, tomorrow we'll be discussing extensively on images, computer vision, tomorrow, day after, uh, and then the day after that also. Maybe we'll be spending a lot of time on images, and then we'll get into. Okay, so 0 to 255 pixel values exist. And then as part of normalization, we already learned this, that you have to normalize the values, all the columns, all the column values, you have to normalize it to 0 to 1. Why should we do? We have already discussed back then. Okay. I shall not repeat that again. In the initial classes we discussed. So you're taking each and every pixel value, your input value, dividing it by 255. If the minimum value is 0, if I divide it by 255, you anyways get 0. Maximum value is 255, and if you divide it by 255, you get 1. So it ranges in the range of 0 to 1. You have your test data. If you divide by 255, again you get this. Okay, so I shall stop here because if I proceed further, we might not have the time to discuss. Tomorrow when we connect, I'm going to walk you guys through what is one hot encoding, why do we do it, and how to actually run your algorithm. That's okay. We'll be a little slow in terms of understanding the programming, but let's understand it thoroughly. Yeah. And quickly, let me give you this link. Friends, please, once again, I'm requesting you all, ask your students, ask your other faculty members to please subscribe and click on notify. We are starting an interview preparation series. Okay, interview prep series. Most probably in the next 1 or 2 days, we are going to start. And all of your students will get an amazing opportunity. We will open up the channel from 12 p.m. to 5 p.m. In this window, anyone can log in. They can ask their doubts pertaining to data science, not AI and deep learning aspects, but data science to get started. All they need to do is just click on subscribe and notify so that they are notified as soon as we go live. Okay, that's a humble request. I am going to post this link if it's not already there. Okay, please subscribe and proceed further with this. And there is also an attendance link which is posted. Okay, there is this attendance link. Yeah, sure, Padma. We shall share with you the code, training data, and test data, and you can practice at your end, certainly. No, there is no assignment. There's no assignment as such. Yeah. And the fee attendance link is given to you all. If you want to get the certificate, you should give the attendance for sure. So please do that. And then we also have a Facebook and LinkedIn. You again, please, that's a request because there are a lot of quiz questions which we keep posting. If you go here down, if you go to LinkedIn, and then if you go to Facebook, we post the quiz questions here. Please follow. If you do not follow, I mean, there is a lot that you would be losing out. Here the questions are posted. Please answer in the comment. Click on comment and answer so that you all jointly contribute to the answers. And please follow. Do not forget that once again. And yep, here we have today's quiz questions. You please comment and answer. This way, you'll be continuously engaged on the interview questions and all that, right? So that is how it works. Okay, so please follow, subscribe here, follow the LinkedIn and Facebook, and give your attendance. Thank you all so much. We shall connect tomorrow and take this discussion further. We'll do something called as vertical projections and horizontal projections, Kranti. That's the algorithm that we use basically. We will do that also. Aruna Kumari, we will do that also in the next algorithm. Slowly we will learn. Slowly we will learn the concepts. Yeah, we shall post on the groups also all these details again, and have a good day. Thank you.